Good evening, friends. Yesterday we discussed about, we started already unit 2 regarding applied thermodynamics. In that, we have seen that what is first law of thermodynamics, and James Joule demonstrated one experiment how work is transferred to heat yesterday. So, I already shown through that PPT. So, go through that video. So, in that class, how algebraic, cyclic integral of work transfer is equal to cyclic integral of heat transfer. So energy is neither created nor destroyed, but one form of energy can be converted into another form. So first law states that heat and work are convertible. Okay, cyclic integral of work transfer is equal to cyclic integral of heat transfer. Okay, so based on that, so we already seen that in unit 1 what is the system, what is the properties, what is the types of systems. Okay, there are three types: open system, closed system, and isolated system. Especially yesterday I have given the brief classification how that study flow means that applied for open system or for closed system means this one flow process is for open system. Open system means where both energy and mass transfer takes place, whereas closed system means where the quantity of mass is fixed. Okay, whereas in open system both energy and mass transfer takes place. Okay, here, so yesterday we have seen that what are the various classifications, okay, for flow process and for non-flow process. Okay, so especially for flow process, even though it is open system, under open system of flow process, again that is divided into two types: steady flow process and unsteady flow process. Okay, steady flow process and unsteady flow process. In this class we are going to derive one equation, that steady flow energy equation based on law of conservation of energy, where the assumptions means what are the basic assumptions in deriving the steady flow energy equations. Only this steady flow energy applied for only for open process. Okay, open process, in that steady flow and unsteady flow process is there. Whereas in steady flow process, why we are specifically concerned about steady flow process means, see, the mass of fluid is same in the entire system. The mass of fluid must be same in the entire system. At the same time, the second condition is the mass of fluid entering the system. The mass of fluid entering the system must be equal to mass of fluid leaving the system. Okay, mass of fluid entering the system must be equal to mass of fluid leaving the system. At the same time, so see here the energy transformation means it must be uniform. See here the heat energy is supplied to the system and it leaves as work. Okay, energy must be, transaction must be uniform. Okay, so based on this study, there are certain, I am taking certain parameters to derive this steady flow energy equation. So Z1, Z2 are the datum levels of height. Okay, Q is nothing but heat and W as work. So energy entering the system as heat and leaves as work. Okay, for this, so M1 is mass and M2 means mass leaving the system. So P1 is pressure, inlet pressure, and P2 is the outlet pressure. So T1, so V1 initial, small, these are the assumptions. P1, P2 are the pressure in Newton per meter square. Small v1, v2 are the specific volume, meter cube per kg. U1, U2 are the specific internal energy, joules per kg. V1, V2 are the velocity of the fluid. Don't confuse about small v1 and this v1. Small v1 represents for specific volume, whereas this v1, v2 represents for velocity. Z1, Z2 are heights. U1, U2 are the specific internal energy. Okay, Z stands for acceleration due to gravity. Okay, Q stands for heat energy entering the system. Okay, so M for mass and W for work. So W for work leaving the system. So the basic assumption I already discussed regarding the steady flow energy equation. Mass of fluid must be same the entire mass of fluid must be same in the entire system. At the same time, mass of fluid entering the system must be equal to mass of fluid leaving the system. So here I write the equation: energy entering the system must be equal to energy leaving the system. So in that, so if you want this derived equation, it is not necessary. Just note this equation. Why? Because based on this equation, we are applying for boiler, we are applying for nozzle. Based on this equation, again we are applying for, suppose, turbine, suppose diffuser or compressor. Based on this equation, what is the steady flow energy equation for boiler? What is the steady flow energy equation for nozzle? So in order to derive that equation, you have to keep it in mind this equation. No need to derive this equation. If you want to derive, I will give it in your notes, no problem. First, basically you recollect, you just know the equation. Okay, it is based on your continuity equation mass in your fluid mechanics. M_v1 is equal to M_u2v2, and not only that, based on law of conservation of energy. Mainly it is based on law of conservation of energy. Apart from that, continuity equation also used in deriving this equation. If you want in detail, I am giving the notes, no problem. But based on this equation, you may be asked a question, especially for applied thermodynamics in your subject. Okay, apply the steady flow energy equation for boiler, apply the steady flow energy equation for nozzle. You may be asked questions like this. So in order to derive the equation, steady flow energy equation for boiler or nozzle or compressor, you have to keep in mind about this equation. Once you you have an idea about this, keeping this equation in mind, no need to by heart or no need to mug up. Okay, definitely once you know the equation, you can apply to anyone. So applying for steady flow energy equation for boiler, steady flow energy equation for turbine. Once you know this basic equation, you can apply it for anyone. How? The parameters, it will be very, very easy. So that's why I am telling you, just note the equation carefully. Why? Because you have to apply this equation to your furthermore parameters: nozzle, diffuser, turbine, compressor. Okay, again there you are going to get some equations. Okay, some equations. So equations will be more. So in order to avoid that, just keep it in mind this equation. So energy entering the system equals to energy leaving the system. So energy entering as heat, where Q stands for heat, Q plus mass, M1. U stands for internal energy, whereas P1, V1, pressure and volume. Okay, Z is the elevation, height, elevation, G acceleration due to gravity, V is the velocity. Okay, so W leaving the system as work plus mass, same parameters. Here the U initial parameters and final parameters. Final parameters: internal energy U2, pressure P2, V2. Okay, Z2 is the elevation or height, Z2. Okay, so V2 is the velocity. Okay, based on this, why we already discussed this topic. H stands for enthalpy. Enthalpy is nothing but your internal energy plus pressure and volume. Okay, enthalpy is equal to pressure U plus internal energy plus pressure into volume. Internal energy plus pressure into volume stands for enthalpy. So based on that one, if you combine this one, you can write Q plus M equal into within brackets H1. Instead of U1 plus P1, I quoted as H1. Okay, if enthalpy is given to you, you can write this equation. If internal energy and pressure will be, if internal any one parameter is given to you in problems, you are supposed to use this equation. Okay, don't confuse. Okay, H1 stands for enthalpy. Enthalpy is equal to U plus PV. Okay, plus Z1Z means this height. So don't confuse about this height. Why? Because the mass of fluid entering the first, especially for steady flow energy equation, for most of the cases, mass of flow entering the system must be equal to leaving the system. So most of the cases, Z1 equal to Z2. In some cases, in some familiar cases, here the heights will be clearly mentioned. Okay, unless otherwise specified, take it as Z1 is equal to Z2. For coming sections, you are supposed to take the parameters carefully. Okay, so in this steady flow energy equation, so this is your final equation. Q plus m is equal to brackets h1 plus z1z plus v1 squared by 2 equals to w plus m into h1 plus z2z plus v2 squared by 2. Both units are joules per second. Okay, thank you. So go through this equation at the same time. Here in the coming class, in the next class, I am applying this equation for nozzle, for compressor. How we are going to apply that one, we'll see. Thank you.